Hey everybody, this is Cynthia, Grant, and Daryl of Raika Technologies. We are thrilled and excited to be back today. This is a co-branded edition of the Raika Show and Incubate This, where we are talking about IoT. For those of you who don't know, that stands for Internet of Things.
Which is kind of a stupid name.
It is kind of a stupid name. And actually, you know what's funny? The guy who is credited with originally coining the term Internet of Things,
He probably doesn't like it either.
actually called it Internet for Things.
IFT.
And much prefers that name.
IFT.
That actually makes sense.
Yeah.
Internet of Stuff.
Internet of Stuff. Internet of... oh, I can't say that. This is a PG show, folks. So we recently have been working with a project, a client of ours, and one of the elements of what they are putting out in the market is an IoT device. It's an internet-connected device. This particular device, a lot of IoT devices rely on Wi-Fi. Makes them quite a bit cheaper. This one actually does have a cell chip because it's designed to be used outside, out in the wild where there may not be Wi-Fi. Interestingly enough, the cost of a Wi-Fi chip in a device like this is about $3. The cost of a cellular chip is $68.
What about a Bluetooth chip?
Like $3.
Okay.
Super cheap. So we'll just jump right in. We have done some actual hardware work in understanding and seeing, the devices as they're being built and the boards as they're being soldered together and all that jazz. But we mostly have been dealing with it in the interaction from the software side. And so Daryl has been working on the pairing process. Mm-hmm. And, this is one of those things I think we all take for granted, right? Because we're like, we sit down and we turn on the thing, we turn on our phone, and it's like, oh, I found this. And it's like, great. And I don't think, if you've never had to do it, I'm not sure that you understand how complex it really is to get those two things to talk to each other and understand each other. Because we're talking binary at that point, right?
Yeah. There's a lot involved. Without getting into the weeds, there's a lot more than, we did take it for granted. We thought, we'll just make a connection, probably HTTP. There'll be some REST server on the device. And then, we talked to the hardware guy and he's like, I've got like 2K to fit everything. Some ridiculously low amount of storage space.
Yeah.
So he's like, I don't have enough room for anything like that. So you're going to have to open a raw TCP socket and send these raw bytes to me. And now we're realizing, we have to go back to the days of packing binaries. And
so for those of you who...
Then you're throwing native script, or some sort of app, mobile platform technology in there, and it's not like doing it necessarily native from JavaScript or PHP or some normal known language that you've been using for a lot of different things.
Mm-hmm.
Yeah, so. I think that was kind of the realization we had the other day was you can't talk, the native script was built upon web technologies, which wasn't itself designed to talk over a raw TCP socket. So as best we can tell right now, native script can't actually do that. So we're going to have to drop down to a lower level on the app itself, Swift, Objective-C, Java, and open a raw TCP socket that way, and then create sort of an intermediary between the native script level and the app level itself, the hardware level.
Yeah. So we have a lot of probably lower level listeners because this is a co-branded show. So talk a little bit about the size. So you said, the research I was doing says most of these IoT devices have storage capabilities that are 16K or less. Relate that to something for somebody who's sort of like the average bear and doesn't understand storage. How many K are in a gig? Like everybody knows what a gig is, right? Like how many photos can I fit on a gig? How many K is that?
10 to the 24 square, or 1024 squared times a K.
So a lot, like a million or something.
Yeah.
Yeah, roughly a million times
Yeah.
a K is a billion.
Yeah.
I mean-
but it's like the good old days.
I don't think most images that you see on the average web page even are remotely as small as 16K. You know, maybe they're 60 something, you know, but they're usually considerably larger than that. So 16K is really small.
It's tiny, right?
Yeah.
I mean, I'm wearing a mostly analog wristwatch, and I think it's got probably more storage than that in it, right?
Yeah. Maybe. Yeah. So that was the average size that you
Yeah,
found?
16K or less.
An IoT device has 16K or less.
Yep.
And so he's got to pack in processing for when we're pairing up the device, but he's also got to pack in the ability to process MQTT,
Yes.
to be able to subscribe.
And now you understand
Publish.
why security is such a problem, because there's no room for a firewall.
Yeah.
I mean,
Yeah. So these are interesting new problems that everybody's running into. And
They're
we
old
as an
problems,
industry,
really.
they're very old problems.
they're old problems, but they're new
It's
to
funny.
a lot of people, I think, like us. You know, people who spend most of their time on the web, they aren't used to having to think about these things. I think they're good in a sense. It's forcing us to think about things that we really should have always been thinking about. With security, as an industry, we're notoriously bad at that anyway. So,
We have a client who is a chief information security officer at a Fortune 1000 company, and we were talking to him, and he was saying, we were marveling that, you know, somebody who's even in tech as much as he is doesn't understand this process that we go through to build an app, to get an app out in the store, to get clients, like all that stuff. It's still foreign to him, and he's a C-level in information security. And he said, well, remember, I actually don't really care about anything that happens before they bring it to me and say, bless it so we can send it out. And at that point, a lot of times the developers are like, we forgot about the security part.
yeah.
So then, you know, there's lots of this stuff that's like cobbled together at the last minute, and it's like security as an afterthought,
Yeah.
right? And it kind of feels like, I think the original intention with a lot of these types of devices was to make people's lives easier, was convenience.
Yeah.
And that's great, but easy and security don't generally go together.
No, not at all.
So it's just kind of interesting.
I mean, yeah, you look at the risk, and in a lot of cases, what are you risking? Oh, somebody can turn my lights on. Mm-hmm. Who cares? Mm-hmm. But it depends on what that is. And most of the time, I mean, the IoT programming has been I feel like a lot like the factory monitoring systems. Or, you know, I like to think of, I watched a lot of nuclear disaster documentaries, and I like to think of, the Chernobyls and the 3 Mile Islands. These systems have tremendous numbers of monitors, monitoring devices, feeding information into a central system constantly. And that's what the IoT stuff has been like. But those were always on essentially closed systems.
Right.
There's no way to hack that from the outside.
Right.
There is probably nowadays, but that concept has always been, it's already isolated, so it's safe. Mm-hmm. But of course, when you're on the internet for things,
Grant's going to call it IFT now.
every week we see data breaches in big companies that should have all that mastered. And so, I mean, as far as the security aspect, it's an issue. It always will be an issue. It always is an issue, because you have a hard time thinking that standard operating procedure for some of those companies is, let's make this work and then possibly throw some security in on the end. So even with the planning that they do, that they presumably do, there's obviously still holes that strangers out there in the world are able to exploit. So it is a case of no matter what you do, there's probably a hole somewhere.
Yeah.
And, it's a lot of times with things, developers, we want to figure out how to make the main thing work from end to end. And once we got that the challenge has been solved. And it's just sanding down the edges a little bit. Oh, and security. Because security becomes more and more of the upfront process as a team becomes more experienced with the overall aggregate technology stack that they're using. And so, in web programming where you're doing standard websites and you might have a PHP backend and all your client-side stuff, it's already kind of a known. It's been done so many millions of times. When you're connecting devices to the cloud and directly to a phone at different stages, there's there's a lot of things that really you can't go out and Google and find, oh, somebody's done this.
Yeah. Yeah.
And
even the way the hardware comes together can create a proprietary way of doing something for that particular device that's unique. So, we had a series of boards, and all we were doing with those boards, we weren't doing any pairing with those on our prototype boards that we put together. But the OS was different on those. They tried to grab as much of the firmware as they could for these units that now we're pairing with, but the OS is different because the chips are different.
Yeah.
And so is Eric an electrical engineer? Or is he a mechanical engineer? What's interesting is we're all software engineers, right? And so we understand all of the different things that we do that goes into making a software project. When you're building one of these devices, you have mechanical engineers, you have electrical engineering, because you have to make sure that you have enough electricity to power all the pieces, but not too much where you're burning out your boards. You got to have,
industrial
design to make sure, how do you make the enclosure as small as possible, and how do you make sure that the enclosure actually fits all the stuff that needs to be in there, and that it's all the specs and the dimensions are correct, but you don't have a lot of extra space.
That it doesn't impede the sensors that are actually reading the environment, and it doesn't contribute to heat buildup.
Because you can't put, it was the GPS chip, I think, that had to have its sort of separate from the board, because you can't put it within a certain range of some of the other things that are on the board, because it takes too much heat from the board.
Yeah.
Even though it doesn't generate that much heat, but these chips are so sensitive.
Yeah.
And so there's all these things that you don't think about. We just go to the store and we say, wow, $200 for a thermostat. That's crazy.
Yeah.
And it's like, yeah, it's not just a thermostat, right?
Yeah. Yeah. Well, yeah. As we said, a lot goes into them. The same applies to our Macs and the power supplies. And people say, why do I have to pay $80 for that power supply? That's ridiculous. Apple's bilking us. And in fact, a lot of engineering has gone into those power supplies.
Yes. That's why, I don't have a good example, but that's why they have the big brick sort of in between, is because that's taking whatever your house or your office or the Starbucks you're sitting at, whatever they're putting out.
Yeah.
And it's doing all this cleaning and converting to make sure that you don't get surges and you don't get weird stuff, and you don't screw up your Mac because you plugged it in at the Starbucks on the corner of Federal and 6th Avenue, you know?
There was an article I saw on some of the knockoff Mac chargers, and he showed the difference. He showed the Mac charger, and there was this literal wall. There was this literal piece of plastic separating these sections, and then he showed the $15 one, and that wall wasn't there. And he's like, without that wall, this thing could easily catch on fire.
Yeah.
So now take that to these Internet of Things, where it's attached to your wall, or it's on your front door, or it's in your car, or it's on your baby bed. And you have to ask yourself, did that level of engineering go into that thing?
Yeah.
Where it might catch on fire because someone said, we can shave off $5 on this thing if we don't put that piece of plastic in.
Yeah. Is that really worth it?
Yeah.
So how is developing, like separate from the pairing process and the actual hardware itself, how is developing an application, you know, a mobile app or a web app for an internet connected device like this? How is it different from the traditional process? You know, and maybe things that you expected, but maybe things that were unexpected that we've sort of stumbled across as we've been in this process.
How does it differ?
Yeah,
Dramatically.
Yeah.
Next.
Next question.
You're so succinct, Grant.
Well, going back to the talk about Chernobyl, not that we want Chernobyl on your baby's bed.
Why not?
We're definitely against that.
3-headed baby.
Can name it
That
Cerberus.
idea that you're getting data coming in constantly and you're just sitting and listening. It's completely different, vastly different from a web environment, you know, that most of us are used to with applications. And you're sitting there listening for devices talking to you. You don't know what devices are on. They just come on out of the blue. They're all over the world. And while this data is coming in, you're storing, you're analyzing, you're reacting, but none of that can get in the way of listening for the next message that comes in. And it's weird.
So
It's
essentially
really
what's
weird.
happening and how this is kind of pretty unique. It's you know, in a web environment or even a mobile app environment, as you're interacting with it, like maybe there's some stuff that's happening in the background, but mostly it's as you're interacting with it, you know, data on time and, you know, processing on time, whatever. With internet connected devices, they're doing whatever their function is all the time.
Yeah, they're not waiting for and they're not waiting for me to say, okay, I got your message.
Right.
They're sending the
they're
next
just sending,
message.
sending. They don't even have a way. Most devices don't even have a way of acknowledging that that's going somewhere. They're just pushing packets.
Yeah, I think there's things in MQTT. There's definitely things that will guarantee delivery, et cetera, things like that. And you know, you can have another end send. MQTT is the protocol that's used in IoT devices, not HTTP. It's a simpler, I won't say the word, the L word. It's a much smaller protocol developed way back, wasn't it, during the oil and gas exploration?
Mm-hmm. Yeah.
And it's, you know, designed to be very small. And there's ways to send both directions, so to speak, basically both sides listening. But then again, if you are going to send commands to your devices, then your devices need to have a lot more going on, and we run into
Which
memory
requires
issues too.
memory and storage space. Yeah.
But the idea that these devices are sending these messages, it's essentially everybody just raising flags saying, here's, you know, I got something to say. You may or may not get it. And the fact that if you've got a central processing concept that has to do a lot with that data, and then maybe start operating kind of autonomously on its own, as we do, where we've got timed warnings going out from the back end, from the cloud, after we, you know, depending upon what we've gotten in from devices that tell us certain conditions, we might start processing things on the back end to deal with that. And then the back end is, you know, this kind of an intermediary between what those devices are saying and what users are being notified of in their environment, and usually in an app. It's just, again, it's weird. You've got, as you said, like, you know, those devices are doing their thing. The cloud is doing its thing, but all the while it has to be listening for an update. You know, we might get a message saying that this device is in a dangerous status, and we start alerting users to the condition that the device is in, and then the device gets turned off. And so we've got some stuff that we have to go clean up and make sure that we don't alert you again. The difference is that in a lot of times in the softer world of just web programming, it's okay if you get little anomalies here and there about, you know, oh, you need to log in again. You know, just you're used to little glitches. You know, you might refresh a page and that didn't show up that time, and so you refresh it again. Okay, but with devices and stuff, people are going to be reacting to what they're being told, and I feel like you have to be a lot more perfect. You really have to think user experience more, because I don't know if forgiving is the word, but there's just something everybody knows they're in front of their computer and a browser.
Versus there's this thing
It's not a
sitting out
crisis.
there that I'm relying on to give me important information that my house is not on fire, or, my air conditioner isn't broken in the middle of summer, my furnace didn't go off in the middle of winter. Like the data for these devices seems, because of the way it's designed, to be so much. I mean, a lot of it is about security. Your Ring doorbell. I mean, even your Nest cameras, your Nest thermostat. If you think about they have bolt locks for doors that are internet connected, that you can lock and unlock your front door, your back door, whatever, through the internet. And it's like, you kind of need to know that thing is really what it says.
Yeah.
Right? It's sort of like if you went to your bank and you're like, oh, my bank, the number is always off by $5 or $10.
Right.
And you're like,
It's
that could
all right.
be a problem, Wouldn't instill much confidence in your bank. And
Right.
so, if you're processing this data and you don't feel like the confidence is there in what you're getting about the data, the processing about the data, then it diminishes the confidence in the device itself.
Yeah, I guess what I'm saying is that, like, when you're running something on the computer to do something, you're not physically affecting the world. You're, it's all just stuff on a screen, and you kind of have the confidence that it'll work itself out eventually there.
Yeah.
But we don't do that with things that are sensing the world and telling us what's going on. We don't go, oh, that's funny, but it'll work itself. We go, holy shit, the house is on fire. Excuse me.
I'll beep it
The
out.
house is on fire. You don't say, well, it says the house is on fire. Let me give it another 5 minutes and see if that comes
See if
back
that's
to
real.
normal.
Yeah.
Well, it's still saying that. I'm not sure.
Yeah. Yeah.
People are going to react. So,
It says
Yeah.
the house is on fire. Maybe I need to clear my cache.
yeah. Did you try turning your house
Turning
off
it
and back on
turning
again?
it off again.
And so it's interesting to anticipate, what will this, user experience has been a term that's been around for a long time, but I think it's a lot more real in a case like this, because it's the user experience is somewhat that device is replacing your own senses on the world. And so your user experience is kind of more demanding in that, because
Is
you're
that
relying
partly
on that.
because we are ultimately the end user? Yes, but there is another device in between that. So I'm thinking for PubTech, this message is coming from the PubCom to the MQTT broker, to an app first, and then to us, and we can be more forgiving because we can make those distinctions or whatever. But the app can't do that. The app has to be very strict in what it's consuming. I wonder if that's part of the problem, is you've got devices monitoring other devices and all this. I don't know. Maybe not.
I think more to the point, if I'm standing in front of my dog, sensing the atmosphere for myself, I'm always going to trust my judgment.
Yeah.
Now you're asking me to have this, what's the word? I'm having a hard time finding words today. I apologize. The word for like a surrogate. Now I have
Yeah.
this surrogate that's like a robot, little tiny robot
Yeah.
that I'm saying, okay, I'm going to trust you to tell me and let me know if there's a problem.
And these little robots are historically not altogether trustworthy sometimes.
Well, I think it's the physical world situation. If I go to my bank and it says I have a zero balance, I know that's wrong. I know that I can pick up the phone and call somebody. I know that it can get straightened out. If I'm driving a self-driving car and there's a bug in that, I'm going 60 miles an hour.
Yeah.
I can't call somebody to straighten out why is the car doing this? Why does the car keep driving towards the wall at 60 miles an hour?
Yeah.
It's immediate. There's an immediacy once we get into the physical world.
Yeah. Yeah.
There's a time factor. Everything's only in one place at one time.
One of the things I find really interesting when this whole concept, so the first concept of a device being able to communicate messages across like not the internet per se, but across a network, was actually in the early 80s, 1982. And over the next 17 years, they debated it. They talked about how would this be useful? How would you ever use it? And by 1999, they projected that over the average person's lifetime, you might have 0.08 devices that were internet connected or network connected for every person on the planet. So when a lot of the original specs were worked out, they were thinking to that level, like a very, very tiny percentage of the population would have one of these devices at most.
Yeah.
There are actually almost 2 devices that are IoT devices for every person on the planet today. And that number is growing incredibly fast. Actually, that data is from like 2016.
I wonder if that's because they couldn't see everybody having... I don't know why they couldn't see this, but they just didn't foresee everybody having
Nobody
a
foresaw
powerful computer
this.
in their pocket.
I mean, we had PDAs. Do you remember
Steve
PDAs?
Jobs foresaw this.
He did.
He actually did.
He did. But you remember PDAs, right?
Mm-hmm. Yeah.
It was a very unuseful thing.
I got in trouble for that a lot in high school, actually.
Yeah. I mean, we had pagers and PDAs. And
I had a Newton.
what was the
Did you have a Newton? That was the
Apple.
Apple's PDA.
Oh,
That was-
really?
Yeah.
We love
Speaking
Apple.
of Steve Jobs, he killed the Newton. But I remember playing with the Newton.
It was very slow
Yeah.
after a while.
Palm Pilot, I think was.
I
was
had
the
a
big
Palm
one.
Pilot.
But you
got one
couldn't
of those
do
too.
you couldn't do video.
There was
no color.
There was some email maybe, but it only had like a couple protocols and
Yeah.
like you had to be like a genius to figure it out. You had to like crack open the back or something. I don't know.
It was a glorified notepad. It
Yeah,
was an
it really
expensive
was.
notepad.
It really was.
And calendar and reminder. I
Yeah.
mean, it was cool. It was amazing for what it did
Yeah.
at the time. But
Well, you had to sync up using USB.
yeah, you
right?
had to.
Yeah.
I don't even know if it was USB at the time. Was it? May have
I
been.
can't remember, but I remember I had a little cradle,
Yeah.
snap it in, and that was the way you sync. So that was way before Wi-Fi was really much out there at all.
Yeah.
That was the late 90s.
Yeah.
So it is kind of amazing that they didn't see that we would all have a computer in our pocket, and that
But that's why it was so revolutionary.
yeah.
Is that
Right?
a computer in your pocket, or are you just glad to see me?
Yeah.
When this thing happened, game over, mind blown. I mean,
Yeah.
that's a game changer right there. And now all of a sudden,
So get yourself one of these.
no, not one of those. That's stupid.
Not one of those. Yeah, one of these.
So I think probably before that made a lot of sense. Like
Yeah.
looking at the total population and population growth and saying, here's sort of the realm of people who are really into tech enough that they're going to want one of these kind of network connected things. I mean, these are uber geeks, right?
Yeah.
It is no longer uber geeks.
And you know what factored into that too when they were saying it was going to be what 0.8? Mm-hmm.
0.08.
0.08 was their thinking at the time. Even though again they saw technology getting smaller and smaller and smaller, they were thinking it's just going to be too big. And now, I mean, what we're doing with the PubCom is what?
Yeah,
It's tiny. It's a
little.
couple of inches by a couple of
I
inches.
mean, it's
Smaller.
smaller than
than a
this.
phone.
It's a
pager.
little bit
Yeah.
thicker, but yeah, like the
yeah,
size of a
basically
pager.
a pager. Although I'm sure there's a swath of people who just heard that and went, "What's a pager?"
What's a pager?
But
What's a
Pagers
cassette
are.
tape?
even
I've
that's
seen that
giant
TV.
compared to what it's going to be in 10 years, right?
Yeah.
That thing will fit on a chip in 10 years. We know it will.
Yep. I mean, that's how you went from the original this to an iWatch.
Yeah. Well, the very first version of the iPhone 2 years prior to the day they launched it was the size of a conference table.
Yeah.
They had all the components laid on a conference table, and
I
Steve
think
Jobs
the
looked at
original
someone.
Microsoft Surface was a table.
It was.
It was.
It was because effective UI.
That's how
had
it
one.
got the name.
Yeah.
Yeah. did you ever work at Effective UI? I can never remember. Daryl and I used to work at a company that was based here out of Denver that was started by a friend of ours, Anthony Franco, called Effective UI. And Anthony is a gadget dude, and he's actually building a new thing that's like a gadget now with this new company he's working on too. But he always had, like, if there was something cool that came out at CES, within a couple weeks, it probably showed up at the warehouse next door to the office, and that was definitely one of those.
Yeah.
Yeah.
Yeah, I remember playing with the Surface because it at the time was the size. I guess iPhone was out at that point, but the Surface was the size of the old Pac-Man, the 2-player Pac-Man tables. I mean, you guys have one actually.
We have one downstairs.
Yeah, it was about that big.
Yeah. And now, I mean, it's about this size. It's about the same size as the Air.
The Surface, yeah.
Yeah. I mean, it literally is a tablet that connects into a keyboard if you want it, but you don't even have to use the keyboard. I mean, and it's a full operating system. It runs all the same apps. It runs Windows 10. That's one area where I think Microsoft has drastically outpaced Apple.
But what that makes me think of is I remember in the late 90s, mid to late 90s, especially late 90s, they were talking a lot about internet connected refrigerators. They all seem to focus on the refrigerator for some reason.
I know.
Sun was pushing that heavily because they wanted Java to be that language, right?
Yep.
But I could never figure out, because I was like, if it can't tell me all that much about what's inside the refrigerator, for example, you're getting low on milk, I'm going to go ahead and add it to your grocery list.
Yeah.
And it couldn't.
Yeah.
Then it wasn't very useful to me. Well, when that technology is that small and it's that cheap to do things like that, plus now we have computer vision that could probably look at the things. There's a camera inside your refrigerator that's looking at things.
So there is one of those now.
Really?
That has a camera, and you have to like calibrate it or something like that, and you kind of, depending on where stuff shifts around.
Put your food in the same place every time you shop.
But it does have these sensors where you can look, obviously, and say, oh, I'm almost out of milk, or I'm out of this thing or whatever. But it can also, if it recognizes your brand of milk, it will get smart. There's machine learning built into it too.
Yeah.
It's an incredibly expensive refrigerator.
Now, but 5 years, 10 years, 15 years, you'll buy it from Walmart.
Yeah, exactly.
And yet, as you said, you have to put your food back in the same place. I can't even get my kids to put my food in the refrigerator, much less back in the same place in the refrigerator. So I don't know how it helps me there, but.
All right. Well, this has been a fun discussion. I think we've had a good time. We hope you've had a good time. Any last thoughts before we sign off with the folks?
It's going to be interesting, and I think if there's a key takeaway, it's that I don't think anybody can fully predict where it's going to go.
No.
Once we have this ubiquity of the Internet of Things, that's when things are really going to get interesting, I think.
Yeah, I would agree. Last thoughts? No?
No.
Okay. Thank you so much for joining us for this episode of Incubate This and the Raika Show. We will see you guys next time.